Hello everyone, in this video we're going to be looking at circular motion. So what is circular motion? We actually see this a lot in our real life. You might have heard about centripetal force or centrifugal force, which is not a thing actually, but you can think of it as having a string that is attached to a rock and you just swing it around and you get circular motion. So let's define uniform circular motion here. Uniform circular motion involves objects moving at a constant speed but with changing velocity. So let's look at the definitions of velocity and speed. Speed only has magnitude, but velocity also has direction. So at a given point in a circular motion, the direction of the vector is going to be different unless it's literally at the same point, which means that even though the magnitude is the same, the direction of the vector is changing, which means that the velocity is changing. Now we need to define two things. The first one is period. Period is the time to complete one cycle. And its units is seconds, just like this. Frequencies, though, is 1 over period, or period is equal to 1 over frequency. Frequency is defined as number of cycles an object complete in 1 second. So here is the definition of frequency. So number of cycles divided by the time. And we use frequency a lot in order to find how much time it takes to do one cycle. When we do real life experiments with circular motion, we usually use, for example, a string attached to a rock, and then we swing it around, for example, 10 times, and then we time it as well. And then we just divide 10 by the time and we get the frequency. And in order to get the period, you just divide it by, so 1 over frequency is equal to the period. Its units is 1 over seconds, so you can also denote it like this. And actually this unit is called hertz. Now we can talk about tangential velocity. So tangential velocity is the velocity at any given point. So here we see the tangential velocity of this motion of the ball. It's going around, it's probably attached to a rope like this, and it is making a circular path. So let's say we just take a picture of this ball and we get the instantaneous velocity of this ball, which is the actual tangential velocity because it's tangent to the force. So the force is here and this is tangent. The formula to find the tangential velocity is 2 pi r over period, which comes from v equals d over t, so distance over time. The distance is going to be the circumference of the oval, and it's equal to 2 pi r, and the time is equal to period, so the time it takes for one cycle. We see two examples of the object getting out of the circular motion. So if there is no external motion, we'll see the A in real life because it's going to go in the direction and magnitude of the tangential velocity. But if there's gravity pulling it down, then we're going to have a motion kind of like this. Now we need to define centripetal acceleration. So centripetal acceleration is the kind of like the acceleration that is holding the ball in the circular path, and we find it like this. So acceleration is equal to the speed squared, actually the velocity, this is the tangential velocity, over radius. As there's an acceleration, we can probably infer that there is a force that is holding the ball attached to the center. This can be your hand or anything that is the string is attached to. Centripetal force is calculated with Newton's second law. So we have the acceleration just here. So the force centripetal is going to be mass times the acceleration, which is v squared over r. Now let's answer this question. Determine the acceleration of an object experiencing uniform circular motion. It is moving in a circle with a radius of 20 meters and a frequency of 0.5 hertz. So let's see what's going on here. So let's first find the period because we'll need to use it for our to calculate the velocity. So the velocity is equal to 2 pi r over period. Another thing you can do is actually this is also equal to 2 pi r frequency. So even though we can calculate it here, we can also calculate it within the formula. So let's plug it in. 2 pi r, so r is 20 meters and frequency is 0.5. These cancel out and we get 20 pi meters over seconds as our velocity. Now we're asked to find the acceleration. The centripetal acceleration is equal to v squared over r. So 20 pi squared over 20. And this is going to give us 400 pi squared over 20. Now we can simplify these and we get 2. So it's equal to 20 pi squared meters over seconds. When a car is turning, it's actually using circular motion and the friction that is from the ground to stay on the road. So the friction is holding the car in the road while the car is turning in a circular path. So we can easily deduce these two formulas and find what's going on here. So the friction force is calculated with the coefficient of friction times normal force, which is actually equal to the coefficient of friction, mass of the object, and the acceleration of the gravity. And the circular force is equal to Fm times v squared over r. Now, we know that these are equal, or they have to be equal because the car has to stay on the road. So we can equalize them. And you might realize that we can actually get rid of the masses because they cancel each other out. So v squared equals r, coefficient of friction times the acceleration. We can infer from this solution that the mass doesn't have to do anything while the car is taking a turn in a circular path. So let's look at other two situations. Here we have a ball that is swung around, and at the bottom it has a velocity of 10 meters per second. And its mass is 2 kilograms and the string is 1 meters long. So how do we find the tension on this rope? Well, there are a couple of forces that is making up the tension here. The first one is Fg, which is caused by the gravity. And then there is this force of centripetal force. The tension is equal to centripetal force plus the force of gravity. So tension is equal to, so let's find the centripetal force here. So mv squared over r plus mg for the gravitational force. The m is 2 kilograms. The force is 10. Actually, I'm just gonna move this around a little bit. 10 squared. And the radius is 1 meters long because the string is 1 meters long plus 2 because it's 2 kilograms, and the gravitational acceleration, we're gonna take it as 10 for simplicity. Let's find the tension here. So this is going to make up 220 newtons. Here we have another example. So this ball is on the top and we're asked to find the minimum speed. In order to find the minimum speed here, we need to find how much centripetal force we need in order to keep the ball at the top. So you can say that the tension here, the centripetal force, has to be at least equal to the gravitational force. And tension, we're going to ignore the tension, or it's going to be equal to 0 because we're finding the minimum speed. So Fg is equal to mg and Fc is equal to mv squared over r. Here we can cancel out the masses and we're looking for the velocity, so I'm just gonna multiply each side by the radius. So this is equal to rg equals v squared, and I'm gonna take square root of both sides. And the velocity is gonna be equal to, the r is equal to 1 and the g is equal to 10. So the velocity is equal to square root 10 meters over seconds. Thanks for watching this video. I hope you learned about circular motion.